Hi there, welcome to today's video. My name is Prabjot Kaur, and in today's video we're going to learn basics. So we're going to focus on how to train a supervised machine learning model. What I'll present is a general framework, so there is no code that I'm going to share today. It's just like a pseudocode. So very basics. When we talk about training a machine learning model, there are several ways we can train a model. One way is using supervised learning, which can be used for both classification and regression problems. For supervised learning, we have to have labeled data. And then other necessary things that are involved is that we have to do the feature extraction, some pre-processing on the data, and then those features are then used to train a machine learning model. And when we train a machine learning model, there are several terminologies involved, such as cost function, gradient descent, epochs. We'll learn all of that in this video. Then, once the model is trained, we evaluate the model to know how good it is on a data set that it has not seen during the training, and that's really end of the training process. I want to point out that in this video, I'm only going to focus on training a machine learning model. We will not go into feature extraction. We will not go into how to do the test train split. We will not do model evaluation. So I'm going to singularly focus on how to train a machine learning model. So if that's what you want to learn, then please stay with me and let's get started. Let's start with the definition of supervised machine learning. So supervised machine learning is one way to train a machine learning model. In this technique, we are given the labeled data. So we have a set of inputs and we have a set of outputs that correspond to each input. So we're given labeled data. Then we want to learn the association between input and output. So we want to learn the relationship. How is a particular input or how is a particular output related to a particular input? So we want to find a model that best tells us the relationship between the input and output, and that's called training a machine learning model. So as you can see in the mathematical form, so we have an input x and we have output y, and we want to learn this function that relates x and y, and this is also called a machine learning model. So once we have this model, then we can use it for many different applications to make predictions on new data. So that's the idea. So key thing to take away that we have to have the labeled data. So let's take a look at two different types of problems that can be solved using supervised machine learning. One is regression, one is classification. For regression, the output can be any real number. As an example, let's say we want to predict the housing price based on a bunch of inputs. So in this snippet, Tx is the house price, and it depends on several different factors. It depends upon the number of beds, number of bathrooms, the square foot, the property type, the restaurants nearby. All of these inputs affect the price of the house. But we don't know how much impact the number of beds, number of baths, we don't know how much impact each feature has on the price. We don't know that, and that's what we want to learn. Because once we are able to learn that association between all of these inputs and outputs, then we can make a prediction on any new set of data where we do know these inputs, and then we can predict the house price. So that's a regression problem. For classification, the example can be, let's say you and your friend went on a trip and you guys took a lot of pictures, and now you want your friend to send you the photos that contain you. So we have a certain collection of photos and we want to identify which photo contains your face, and then we want to send that photo over to your phone. So here the input is set of images and the output is whether the image contain your face or not. So that's an example of a classification problem. More specifically, it's an example of a binary classification problem because we can only have two possible outcomes. So these are two types of problems that we can solve using a supervised machine learning. So in order to learn the association between the output and the inputs, we want to train a machine learning model. So we have to first pick a machine learning model to train. There are several models available, for example, linear regression, logistic regression, decision trees, and several more. So once with some prior knowledge, we know which model we want to train, then we start the training. So for this lecture, let's pick a linear regression model to solve the house price prediction problem that we saw in the previous slide. You probably already know that the linear regression, the model looks like this. So it's basically the linear combination of inputs. X1, X2, X3 are different types of features that we saw in the previous slide, such as X1 could be number of beds, this could be number of bathrooms, this could be a property type. So you can have many more inputs. I just took 3 just to keep things simple. So this is a linear regression model, and we can also rewrite it in the matrix form, where W is the set of all the W's and X is set of all the inputs. So this is a linear regression model. So here, what we do know is from the data, we do know what is X1, X2, X3, and we know what is corresponding price of the house. What we don't know is this W0, W1, W2, W3. So we don't know how much of an impact X1 has on Y, X2 has on Y. So that is what we want to learn. And that's what we call training a machine learning model. So essentially, we are trying to learn these weights. We also call them parameters. Okay, I briefly talked about this in my previous slide. So for the linear regression, when we talk about training a linear regression model, what we are saying is we want to know what these weights are. W1, W2, W3, again, these are also called parameters. So we're given input X, and we're given the output, but we don't know what are these weights, and that's what we learn through training. So in this slide, we'll jump into the general training framework. So firstly, we don't know the weights. So we'll start with a random set of weights. Then, once we know these, once we decide these random set of weights, then we calculate the output. So for example, if we go through the steps slowly. So let's say your data set has n number of samples. Then for each sample, we will calculate what is Y given X1, X2, X3 and the random set of weights that we chose. So this Y is the predicted house price based on these random set of weights and for a given input. Now, this predicted Y may or may not be the same as the actual house price. So we want to know what is the difference between this predicted and the actual house price, because the goal is to predict, to make a good prediction. So we find the error. So the simple way for this problem is we'll just subtract this predicted output from the actual output, and then we take the square of that. The reason why we take the square is because the predicted can be either lower or higher than the actual, and we don't want to deal with these positives and negatives, so we just take the square of the error. So we have the error squared for each and every sample in our training set after we do this prediction. Then to have one metric to know what is the error, we define a cost function for this particular model that we have decided to use using this set of parameters, random set of parameters. So that's what cost function is. So in this case, the cost function simply will be whatever error square we calculated for m number of samples, we'll just take the mean of that. We call it mean squared error. So that is our cost function. And why it's called cost function is because we want to penalize the model if the error is too large, or if the so the goal is this cost function, if it is too large, which means the error is too large, then that's not a good model. So we want to minimize this cost function now, and that's the goal. And the way we minimize this cost function so that the predicted value is close to the actual value, we have several optimization algorithms to optimize this cost function. And one of the common algorithms used is called gradient descent. And we will study that in the next slide, but for now, just keep that in mind. So we minimize the cost function using the gradient descent, and then we update the model parameters. So when we do the gradient descent steps, we are able to get this new set of parameters. Again, in the next slide, we'll cover the details, but for now, the gradient descent, we get the new set of parameters. Then we go back and repeat again from step 2. So what we did in step 2, 3, and 4 is called a single epoch. And we repeat this process. So we have many epochs, and we repeat it until this cost function converges, which means it's close to 0. And when that happens, then what we get is we get the final set of weights, which are satisfactory, which have minimum cost. So that's our final trained machine learning model. So in the next slide, we will study what is gradient descent, how do we minimize this cost function. So this is just a general training framework for supervised machine learning. So let's move on to the next slide and go into the details of gradient descent. So what is gradient descent? As we learned in the previous slide, the overall goal is to minimize the cost function. The cost function that we have chosen for the linear regression is just mean squared error, but there can be many different types of cost functions. So we'll leave the intricacies out of this discussion and just simply keep things simple and just focus on the mean squared error cost function. So as long as the cost function is convex means it looks like this. We know just by speculating that cost is minimum at the bottom. So in order to, let's say we make a prediction based on certain set of parameters and we find the cost is this much for the initial set of parameters that we chose. The cost is high and we want to keep minimizing that cost until we reach some convergence point. We will know that we have reached the convergence point because if we keep doing it, then we will start to increase cost again. So the way gradient descent works is it tries to find this minimum cost and eventually the new set of parameters by taking these small steps. So what's happening in each step, and just want to clarify, if we go back to the previous if we go back to the previous slide. So in each single epoch, we take one gradient step. When I say gradient step, to make it more to make more sense of it, we can just say we take one gradient descent. So we are descending. what happens in every step? So at every step, we take the derivative of the cost function. And why do we take the derivative of the cost function? Because we know that one way to find the minimum for our function is to take the derivative and set it equal to 0. So here, rather than doing all of that in one step, we do in number of steps. And at every step, we take the slope of this function. And we just keep moving in the direction of decreasing slope. Then, whenever we take each step, gradient descent step, we update the model parameters. And the way we do that is using this equation. So we have the old set of parameters. So if we start from the beginning, we have this random set of parameters. Then we add to it the learning rate times the derivative of the cost function with respect to w. So we already know what is the derivative of the cost function. It's just the slope of this. The learning rate tells us how big or small these steps should be. Because if we take two big steps, then we may miss this minimum. We may jump like this. And if we take two tiny steps, then it will take us very long to reach to this minimum. That's what the learning rate is for. So at every step, what we are doing is we're updating the model parameters by using this equation. So we take the old set of parameters and add to it the learning rate plus the derivative of the cost function. And then once we have the new set of parameters, then we repeat what we saw in the previous slide. So once we get this new set of parameters, we go back, recalculate y or make a new prediction, find the cost function, and then again take the next gradient descent step, update the parameters, find the cost function again, and we keep doing that until the cost converges to some value. So that's really what gradient descent is. So it's an optimization algorithm. That's pretty much it for this video. So what we learned is we learned how to train a machine learning model using supervised learning. And we mostly focused on how to train a model, and we learned what is a cost function, how to minimize a cost function using gradient descent, and other terminologies that we used were what is a epoch. Now there are several types of gradient descent such as batch, stochastic, and mini gradient descent. What we covered in this video was called a batch gradient descent. The reason why it was called a batch is because as we go back here, what we are doing is we are taking the cost function for all of the samples at once, and then we minimize that cost function after for all the samples at once. So that's why it's called batch gradient descent. And there are several more such as stochastic and mini gradient descent. And if you're interested, I encourage you to look up what these are. And that's all for this video. And thank you for watching. If you like the content on this channel, please consider subscribing. And I would love to have you as part of my YouTube channel. Thank you so much. I will see you in the next one. Bye.